So in order for our Axiom system to behave in the way we want it to behave, we wanted a statement that we had to prove in our last video. So this is the statement that we want to prove, but the process by which we will be proving it is called proof by contradiction. It is a very powerful technique, and great many problems of mathematics have been solved using this technique. One great example of it is Fermat's last theorem. We know about Fermat's last theorem, all of us have heard about it. It is the longest standing mathematical problem, and Dr. Andrew Wiles finally proved it using this technique of proof by contradiction. So let me show you an easy example, a very intuitive one, just to highlight how this system of proof by contradiction works. So we look at this example which says that this is not the case that this is an orange. Now this is the statement that we want to prove. And how can we prove it? So the first part is to suppose that this were true, and the second part is to show that this is absurd to believe that this is true. And once we have shown that this is absurd, the supposition is absurd, the counter truth or the counter case must have been true by default. So this is how it works, and here we have used this system to prove that this is not an orange, and the statement hence is true that this is not the case that this is an orange. So how can we prove theorem 1 using proof by contradiction? So if x is not equal to y, then the successor of these numbers can only be two possible things. They can either be equal to each other or they cannot be equal to each other. Now we will show that one of them is true, and the supposition which is contrary to this statement has to be false because it is absurd. And to show that this is absurd, first we will have to write axiom 4. We will have to recall what axiom 4 is. So what was axiom 4? So axiom 4 stated that x prime is equals to y prime, then x is equal to y. But this statement is in stark contrast to our axiom 4, which means that this is absurd to believe that this would be true. So what we are left with? We are left with this statement, and hence we have proved that this statement has to be true because the counter case is absurd in the light of axiom 4. In our next video, we will use induction to prove another important case.